Unfortunately, Asya wasn't able to make it today. She had to leave a little bit early due to the snow. Those are Americans, right? It's like, um, but I'm happy to have Jay, Jeegar, and Pat with us today. They will be here to answer any technical questions that you might have. I'll be running around the room and handing you the mic if you have any questions. But let's get started with each one of you. And why don't you tell us who you are, what do you do at MongoDB, and what are your technical areas of expertise where you can answer questions?
Hi, my name is Jay Runkel. I am a distinguished solution architect at MongoDB. I've been with MongoDB for around 10 years almost now, and I was with another document database company for almost 5 years before that. I don't know, you can ask me anything. I'm pretty familiar with most of the MongoDB platform.
He wants data science questions. Hey guys, I'm Pat Wendorf. I'm also a solution architect here at Mongo. I've been here for 7 or 8 months now. I'm actually a specialist solution architect on the search side, specifically the new Atlas search. That's not new anymore, I guess, but the Atlas search product. My background is a whole lot of search use cases at a bank that I used to work at, RBC. Some of you are probably from there. As well, I used to work for Elastic on search use cases as well when I was there, and Hortonworks in the big data industry prior to that. So if you have questions about Hadoop, I don't want to answer them.
Hey, good afternoon, everyone. My name is Jeegar Ghodasara. I'm also a solution architect, but I'm local in Toronto, so I'm based here in Toronto. I've been with MongoDB now almost 5 years. And before that, I have spent 14 years with IBM in different database roles as well. And yeah, you can ask me, I guess, pretty much anything around MongoDB related document model, operation, MongoDB Atlas, anything goes.
All right, so who will be the brave soul to ask the first question to our amazing panel today? That's going to be a long afternoon. Why don't I guess get us? Oh no, there's one here. So let me hand you the mic.
Do you guys recommend the use of, for JavaScript applications, of Mongoose as a driver or the native Mongo driver? Which one do you think is best?
So with all of these tools out there, whether, doesn't really matter which language, I think the trade-off really comes down to, convenience and maybe simplicity for the developer. Maybe if you find features of like Mongoose that are going to be helpful. So that's in the pro column. What you find in the, let's say the negative column, let's put there, are sometimes performance. So like if you had a use case where you were doing tens of thousands of queries a second, I would recommend going directly against the driver of whatever language you're using. The other issue is sometimes these frameworks or whatever are behind the MongoDB releases. So you can be in situation, I find it most often with something like Spring, in Java, but you can be 6, 8, 9 months behind their update to incorporate the new Mongo capabilities. And sometimes that can be problematic for organizations. So that's how I would balance it off. If you find that Mongoose is going to make your development life a lot easier, use it knowing that, assuming it's not a really high throughput application, knowing that you may be somewhat at a disadvantage in terms of adopting new Mongo capabilities.
So today I heard for the first time about the new serverless option on the Atlas clusters, the serverless cluster option. We have a use case where our traffic spikes significantly. It's a virtual event platform. So when the events happen, there's a lot of traffic. And when there is no event, there's zero traffic. For that type of a use case, what I currently do is I scale the cluster up and down between an M10 and an M30. Would you recommend going with a serverless? Would it be able to scale up fast enough, considering that we know when the load is coming?
So I think it certainly seems like it might work. I think I would try it. That would be my, if you have like some sort of workload tester or something, that would be my recommendation. Or, we might have to just like dig into the, happy to have a conversation later where we kind of dig into the exact numbers. But to me, the safest thing with any type of situation like this is to just go ahead and try it, prove it out before switching. But it should, I think it has the potential to save you some money, I think. Yeah.
Thank you. So I have a question about key rotation. I was recently having to do a bit of work with client-side FLE, and I noticed that you could have a local stored key, but you could also have it stored in some kind of key vault. But when it comes to stuff like TDE and backup encryption, instead of a key vault, it's specifically KMIP that's recommended. What's the reason for that?
So for FLE or for the backup, because there's two different things. So for FLE, we don't have a good way to rotate the keys today, but we have a FLE 2.0 coming out soon, which is under private preview, I believe, right now, which has some like features to be able to rotate your keys automatically, like more easier. Right now, you have to probably rewrite the data to rotate the keys for FLE. Now for backup, we integrate with the, is it Atlas backups or the on-prem?
Oh, sorry, I should specify. I'm on-prem in this case.
On-prem, right? So for on-prem, you are integrating with the KMIP solutions, and you will be rotating master key through the Ops Manager. So if it's managed by Ops Manager, you will be able to rotate the keys through the Ops Manager.
Okay, so maybe so.
So what happens is, so let's talk about how the encryption works with MongoDB first. So when you encrypt MongoDB database using the KMIP solution, there's a 2 layers of encryption happening. So one is every database gets their own encryption key, and then we take your master key to encrypt those database keys. So when we are rotating the keys, actually, so that's sort of like an envelope encryption technology, right, where we have like a key encrypting another encryption key. So when we are rotating the keys, we are actually only rotating the master key. So that means that it allows you to rotate your master keys, and you may need to keep your older keys to be able to access your older backup, right? So that's how we're going to roll out the keys, and we do it in rolling fashion in a multi-node environment. So we're going to rotate the keys node by node as well. Does that answer your question?
So maybe just so I could understand, is KMIP a solution for client-side FLE then? Because I don't remember hearing about that specifically.
So for FLE, the cloud-native key providers are the integration. I believe the KMIP was on the roadmap. I don't know if they've released that yet or not. But for FLE, we support the key provider. It's not a KMIP protocol in the cloud. So but all 3 cloud providers, key services, so it integrates with those 3. The on-prem KMIP was on the roadmap. I don't know the date off the hand, but we can check for that. But that was on the roadmap to be one of the solution for the key provider as well.
Okay, thank you.
You have anything else? Somebody's pointing over here. I'm not sure. No? Okay. Got one there.
Hi. Good afternoon all. So I have one question, a couple of questions actually. One is on the search use cases where I want to, where I've heard in the morning that there are window functions available, but I'm looking more like a neighborhood search. I have a postal code. What are the neighbors around me? Kind of a use cases that I'm trying to solve on a different set of data attributes. Is it possible using Mongo?
So you're talking about a use case where you have, is this like an app with location information and you're trying to find who is around a particular point?
I would say it's a network, kind of a network of devices. I want to find out
So, okay, so.
connected devices to that network.
Yeah, so our near operator is really kind of designed around dates or integers or GeoJSON points. So the idea is that there'd be some sort of location data. So when you're talking about your network, is it stored in your document model like a graph where things connect to other things? That's actually a fairly good question. You could.
And is near the number of edge hops between something, or is that how you define near?
Actually, I'm trying to find a fault in the network. Say, for example, what is the impact because of that particular problem at that particular device?
Yeah, see that might be just a typical Mongo type of query use case. You'd be able to. So if you're using the graph pattern in your document, you should be listing all of the things that whatever entity is connected to, and those connected things, like if you were to query, hey, like I'm gonna knock out this router right here, you should have an updated document with all the things that are connected to it. So then you can query and say, what are all the things connected that we can find? So here.
So there is a graph operator, graph lookup in MongoDB. So you could, if you have your, let's say each document is a device, and then you've got a field that defines kind of the network connections from that device to other devices, you should be able to, from any device, issue a graph query and find out all the other devices that it can see. So you could delete an edge and then rerun that query and, figure out what things get disconnected.
Okay, thank you. So,
yeah, I'd look at the graph lookup operator.
And one other question is around relational versus Mongo, where it was always a confusion around whether I have a nested documents use case, same graph in this situation. Do I need to store them as in multiple collections, or do I need to store it as a big glob or a blob?
So the great thing about Mongo is you can have a single collection and have documents of different shapes, right? So you could have, maybe, one type of router has different fields on it than another type of network switch or something like that. You can store those all in the same collection and then just issue the graph operator across all those documents. I think it's probably, in your use case, probably a single collection sounds like it's going to work the most efficient. I mean, in MongoDB, databases and collections are really kind of for the developer, like to organize information. There's, because there's no requirement that all the documents have the same structure, you could literally take any Mongo app that you've built today and put all of the data in this one collection, and everything's going to work fine from the database perspective. It just might be a little bit more awkward. It's easier for people, right, to know that my customers are in this collection and my products are in this collection, but it's not really required.
Thank you. I'm glad I'm not in front, because whenever it comes to graph lookup, I'm like completely out of it.
Any plan to support HashiCorp Vault for encryption at REST purpose, where we use customer managed key? Currently, I think you support only key management service provided by the cloud provider. So I'm talking about MongoDB Atlas, by the way.
You're talking about Atlas, correct? HashiCorp Vault, I have not heard on the roadmap yet, no. But we can double check. If you work with our MongoDB account team, we can always talk to the product management on your use case, and we can. Will Chav is the best, actually. He's my mentor, so you're asking the right person.
Thank you. I work for an e-commerce company. For us, facets, fuzzy search, recommendations are very important. We currently use a third party, and we have to send a lot of information, and they index every hour, so our information is out of sync for a periods of time. How can I sell to the stakeholders that we could use the native functionality of Mongo instead of paying for an extra service that requires these jumps and extra stuff?
Yeah, that's exactly what Atlas Search was designed for. So I'm going to be doing a session, I think around 3:15 or 3:45 or something. We're going to talk a little bit in depth about Atlas Search. So in your use case, the way we've architected it is that Atlas Search is going to live alongside your MongoDB node in your Atlas profile. So you deploy your Atlas profile, you deploy with whatever size makes sense for whatever your workload is. When you create a search index, what it's going to do is it's going to, and we'll show you in the other session how we create these indexes, but it's basically going to reach into your collection. It's going to grab all the data that's in there. It's going to index it. And then it's going to consume the op log that Mongo uses to keep track of all these different changes. And it's going to sync all of that data almost in real time. We don't like to use the word real time, but almost in real time, into the Lucene-based search process that we have. So because we sync over localhost, so the two processes are physically living in the same virtual machine, we have this kind of byproduct of being one of the fastest syncing search engines on the market right now, because you're not really doing any network hops to sync your data between, and this is obviously with a caveat of, your Atlas profile has to be an appropriate size so that you are not, causing excessive load on the Mongo side or the search side. If it's sized correctly, you should be able to get 1 second or even sub-second changes that are happening in your Mongo collection to your search. This is huge for e-commerce because some customers I talk to have, this one in particular is running about 9 hours between their changes in their system of record over to their search engine. And that 9 hours is resulting in kind of like major customer, user experience problems. Because a customer goes in, they do a search, the search tells them, hey, there's product here. They click into the product page, boom, it's been out of stock for like the last 6 hours. So this is the types of problems we're hoping to help you guys with, is these types of, I need it more accurate, I need it now, and really what we should do is feel free to reach out to, I guess, Mongo or the account team that you're currently working with if you're already on Atlas, and we can set up a conversation to make sure that you have, that we have 100% of the features that you're looking for to support that use case.
I'm going to use Atlas Search now.
So just to add on that, our team can also help you to build a business case that you might need to go to your superiors to kind of explain the TCO comparison between what you are paying to the third-party solution today compared to, so we can help you with that as well.
All right, we've got another question here.
So I have 2 questions. We run an on-prem solution. So my first question is, do you have any tips off the top of your head for bare metal deployments, in terms of file system usage? Should we use striped? Second question is, at Mongo World, it was recommended that we use Mongo 4.4, given that we don't need to use time series databases. Does that recommendation still stand?
So I'll take the second question first. So from a version recommendation perspective, we always recommend latest stable version. Now, so the latest version right now is 6.0. It already has probably a couple of fixed packs and everything, so that's probably a good version to look at. We have a yearly major versions coming out, and we also end of life every probably 3 years now because we are going more aggressive release cycles. So you want to always want to be only one major release behind. That's what you should strive for. Because it might take some time to do application testing and everything when you do major version upgrade. But I don't recommend staying at 4.4 anymore. You should be at least on 5.0. If you can, you should go to 6. To your first question on the on-prem deployment for the hardware configuration, MongoDB, we can run MongoDB on VMs, Kubernetes, hardware, doesn't matter, right? It all depends on the performance requirement, what you want to get out of MongoDB. If the single-digit milliseconds counts for your reads and writes, then going to bare metal with the really fast SSD is kind of going to help you. But from software perspective, we don't really have a hard requirement that you must be on the bare metal, you must be on the VMs or containers, or even like in the cloud right now, there's pretty much no bare metal, right? Everything is virtualized anyways, right? But we still get the same performance that that we could desire. Any specific reason you asked that question?
Yeah, we can't use the cloud. So and we're deploying bare metal machines.
There's nothing wrong with deploying bare metal. In fact, you might get more consistent response times from MongoDB because you are running on bare metal. So we have seen customers getting really stable throughput in the mission critical applications when they're using bare metal.
One other thing, starting in 5.0, MongoDB added this, what's it called, version release capability. So you can deploy MongoDB 6, but tell it to emulate MongoDB 5.0. So the advantage to that is you can continue to upgrade, MongoDB, the database, but keep essentially the API, the query language, back at the older version. So that'll allow you to keep up with maintenance releases, but not require like applications to be constantly upgraded. But yeah, so you gotta get to 5 at least to have that capability though.
This morning there was talked about the column store index flavor. I would really like to hear more what the use cases are for that.
Yeah, so if you've ever used MongoDB for analytical use cases, what you really find out is when you start doing, dollar groups in the aggregation framework that have, let's say you start getting over 1 million documents. So you want to do a group over 1 million documents or something like that. That's when you really, most people want Mongo queries, even analytical queries like that, to take less than a second. And once you start getting that 1 million range, it starts to get really hard to meet that requirement. And sometimes you're in 10, 15, 20 seconds. So what the column restore is a special index that is changing the way the data is stored. So things like groups, analytical style queries can be executed much more efficiently. So it's kind of a feature that's in a lot of databases that are kind of engineered for analytics.
When it comes to the management of priority and votes, is it best to take the approach of automating using something like Mongo Shell or to push that through API calls to Ops Manager?
So if it's managed by Ops Manager, we have to go through by Ops Manager because Ops Manager is controlling. So it's better to do it through Ops Manager API. Make sense? We can talk more.
And right there.
Hi, my company also work in the e-commerce space, and we leverage a lot of application pipelines to process our data and transform our data. Recently, we find out that using application pipelines with a lot of stages actually take quite a long time. So is there any recommendation on the number of stages we can have in the application pipeline?
So it's not as much as the number of stages, I think. It's more, there's blocking stages, right? So if you do a match, let's say any stage, doesn't matter. Let's say match, right? As MongoDB can be sorting through the indexes and the documents and pushing data through the match to like the next stage, which is maybe a project. And that's a non-blocking stage. So that the documents can actually be flowing through multiple stages simultaneously. But eventually, probably in the pipeline, you're going to hit a stage like a group or a sort or something. And at that stage, in order to do a group or a sort, it needs kind of like the entire data set before it can push any documents through the pipeline. So what you'll find is you could have a lot of non-blocking stages together and very quickly start getting results to the application. But once you hit a blocking stage like a group, you kind of have to wait for everything that happened before in the pipeline to complete before it can get on to the next stage. So that's going to be, kind of a limitation. So, all right, so what can you do about it? There's a couple things. We talked earlier, the columnar indexes are going to help with that. If you Google MongoDB slot-based execution engine, you'll see that one of the things that's currently in progress right now is we are reworking a lot of the underlying mechanism on which queries are planned and evaluated, and that's called the slot-based queue. And so in MongoDB 6 right now, some queries go through that new engine, which we've demonstrated is anywhere from like 5 to 10 times faster than the old one, and some queries still go through the old one. So what you can do is you can Google that, and it'll show you the criteria right now in our docs of what causes a query to go through the old engine and what query goes through the new engine. So I would look at that, and sometimes it's just like it's a simple change that doesn't really have any big impact. That'll allow you the new engine, you'll see a big improvement. So, you know, I would kind of look at that, you know, keep track on the columnar indexes. I think they're available in kind of the 6.2, which is kind of a development release, so you could try that there. But those would be kind of my guidelines on kind of how to. But in some ways, you know, if the query is the way it is right now, it's going to work the way it is, unfortunately.
We probably have time for one last question. It's your last chance.
Unless it's search, then you have
We've got one.
It's okay. Hi. So I guess it's an architecture question. In the database that my company uses, we're at a point where there's a series of maybe 4 or 5 nested arrays with objects inside each of those arrays, and it's getting to a point where when we're querying and iterating over data, it slows down quite a lot. So my question is, what could be a better solution to the way that we're building our documents and our collections in terms of trying to manage all of these nested arrays with objects with more arrays and things like that? Is there a...
Okay. I mean, so have you looked at maybe breaking up these arrays and putting some of this data in other collections? I mean, if the nested structure of the documents is kind of problematic, often separating them out may, because if you separate out some of those nested sub-documents, right, then you can index those sub-documents directly, right, and that's going to enable you to find them without doing kind of all those looping through stuff.
Yeah, I think that's a great solution, and I guess my question back would be, then to do nested populates, for example, to then query a new collection, at what point should I consider, okay, this is too many nested arrays, this should be a new collection, which I would do a populate on instead?
So this is great intro. I'm giving a data modeling talk at 2:20, so I encourage you to attend that. But really, if we were going to, like, let's say this was a consulting engagement and we were going to sit down and solve this problem, what we would do is we would just build a list of all of the queries, or at least the most common ones that your application is going to execute, and compare the different approaches against which is going to make those set of queries perform well, as well also easy to write for the developer, right? Because sometimes, I don't know if you're using the MongoDB update syntax where you can kind of update nested arrays. That can be a little bit complicated to write. So you got to balance off both of those things. What's going to perform well in the database, what's going to make it easy for our team to develop and maintain, and just trade off the different options is really, I mean, in the schema design, document modeling in MongoDB, that's really, you always just look at the set of queries you have to implement and come up with a document model that's kind of going to be best for that set of queries.
So, thank you so much. You said there's a data modeling session at 2:20? 2:20, yeah. In the other room?
Yep.
Good. Well, thank you so much for your time. If there's any more questions, don't forget there's the Ask the Expert booth somewhere right here where you can book an appointment and ask questions to some of our experts. And with that, I'd like to just give a warm thank you to our 3 panelists today.